So we're here at the IDTechEx here in Santa Clara. So who are you?
I am Kayvon Karimi. I'm the general manager of the wireless MCUs at Atmel Corporation.
So Atmel is pretty big at doing MCUs, no?
Absolutely. So we have over 40,000 MCU customers, from the smallest L family of devices that we just announced last week at Electronica using M0 Plus, all the way to Cortex M7, which we announced again at ARM TechCon a month ago. We're very much involved with MCUs and a long heritage of MCUs.
40,000 customers, that means 40,000 basically companies using it, right?
Uniquely, absolutely.
And each of them making millions, or how does it work?
So it's as you get involved in the Internet of Things and you look at people who are working on edge node devices, you see these are MCU players. A lot of these guys are smaller companies. They're in the industrial market, and they're smaller players. But that's where the innovations come from. So as you're familiar with Arduino, all Arduino Unos and Arduino Zeros, they're using Atmel MCUs in them. And that's where majority of the innovations are going to come from smaller players. So the 40,000 customers for us, we look at them as these are the innovators of the future of the IoT.
So you said all the Arduinos, like the ones that were before that were using ARM, was that Atmel?
That was Atmel. That was our AVR processor, which is our 8-bit processors, and we have Arduino Unos, which are ARM-based processors, and we just announced actually our Arduino Shield, Wi-Fi Shield, which again uses our Wi-Fi built from the grounds up for battery operations, and it's one of the top 100 EDN. It just showed up in the EDN list as one of the top 100 innovations from this year. Based on ARM processor as well as, of course, our Wi-Fi technology.
So what's this new ARM Cortex M0 Plus that you launched?
So this is our L family of products. This is the one that was built from the grounds up for IoT applications, for battery operations. And if you look at it from a core mark benchmark, it beats the closest competitor by 3x. So in terms of microamp per megahertz, it's by far 70% more efficient than the closest competitor that's out there. And it's an example of the new portfolio you're developing focused on battery operations for Internet of Things, edge node applications.
So this is the lowest power consuming ARM processor ever.
This is the lowest consuming ARM processor, 32-bit microprocessor that runs on batteries, depending on the type of application, runs on batteries for years.
So can you last for 12 to 15 years, like you said in your presentation?
It all depends on the use case, but absolutely, my Wi-Fi can run on 2 AA batteries for years. Again,
your Wi-Fi?
My Wi-Fi, the ARM processor obviously can run actually on more. It all depends on the use case and the application you follow, but it's the portfolio for us is being built from the grounds up for battery operations. So target is battery operations, coin cell, and AA's and AAA's for years of battery operations. If you look at consumer, consumer is looking for a consumer market, your target should be 4 to 5 years of battery operations. If you're looking at industrial, your target should be 8 to 12 years of battery operations. And that's a main driver for the portfolio that we're building for IoT edge node.
So Wi-Fi. Who's making Wi-Fi in this planet, and how big is Atmel with that? And what's your specialty in that?
So there are a lot of Wi-Fi players, actually traditional connectivity players, that they have retrofitted the Wi-Fi that they develop for typical application for mouse and for regular connectivity. Excuse me. And now they put an IoT tag on it. Ours was built from the grounds up for IoT edge nodes and battery operations. So we're not after high bandwidth, MIMO multi-antenna type of applications, multimedia distributions. We're after wireless sensing networks. So our Wi-Fi is tuned for very low leakage, going to sleep really fast, waking up really fast, memory retention, things that are required for using Wi-Fi in command and control system for IoT applications.
So this is ultra optimized Wi-Fi, ultra optimized
for battery operations.
Silicon for the wireless
for battery operations, absolutely. And in fact, under NDA, we're very open to discuss it with you. Even our footprint of our Wi-Fi is about 30% to 60% smaller than the traditional players' Wi-Fis that are out there today. So extra silicon that they carry means extra cost, extra power consumption. This was built from the grounds up for battery operations.
So how do you optimize? How do the engineers work on designing the chips to make them so optimized? What goes into designing this?
So there are a lot of tricks, but it starts with the use case. It starts with understanding the IoT applications. It starts with looking at it specifically for IoT applications, as opposed to saying I'm building one product that's going to match for all these family of categories of applications. You focus on it as this is for battery operation, for low bandwidth command and control IoT type of applications. And if you start from there, then you make choices that are focused on a Wi-Fi that is not always on, like your access point, the Wi-Fi that is targeted to go to sleep real fast, wake up real fast. You make design choices that makes it smaller, makes it more focused on sleep current as opposed to active current, and starts from there, and then innovations that our RF engineers bring in, which make very compact RF lines.
So what is the 802.11ah? Because you talked about this, and this is a new special one, or what is this?
So AH is the future of Wi-Fi for IoT type of applications. It goes down to ISM band in 900 megahertz, sub-gigahertz, so the range is higher. The bandwidth is tuned for command and control. It's lower bandwidth, longer range, lower bandwidth. Obviously means lower power consumption, longer range, very beneficial when you're talking about for in-building penetration. Again, all of that comes together. 802.11ah is the future of Wi-Fi for IoT type of applications.
Is it ready, or is it just people talking about it?
Standards are getting frozen, but you will see prototypes from us and our competitors by Q4 of next year and Q1 of 2016.
So this is coming up, but it's not white spaces, right?
It's not. It's in ISM band right now, but
it's near the white space, but it's not it.
It's not. But so there are other technologies that are based on actually our silicon. Our partnership with Sigfox has been announced. It's based on again sub-gigahertz frequencies for the wireless sensing networks that are optimized for wide area network coverage of IoT type of applications.
All right, so there's lots of things that are going to happen in the future. Like, what did you like? You had a big presentation there. What were you talking about?
So it was describing the topology of wireless sensing networks and the infrastructure that you need for IoT. It talked about the service delivery framework. We're a member of OIC. We're a founding member of OIC, Open Interconnect Consortium. How important it is as an industry for us to come together to establish the framework for service delivery and for communication between the devices. Then it was about the type of communication technologies that you need. Again, from an Atmel perspective, we support Bluetooth, Wi-Fi, 802.15.4, different flavors of it, whether it's 6LoWPAN, whether it's ZLL and Zigbee, as well as sub-gigahertz. So from our perspective, we support all the technologies that are required to support IoT. Now, the thing that the ad special goes back to the heritage of Atmel, which is focus on power consumption, and we built everything from the grounds up, whether it's the MCUs, new portfolio for IoT, as well as our connectivity, all built from the grounds up for battery operations.
So OIC is an important thing.
OIC, Open Interconnect Consortium, very important future of IoT service framework. for cooperations between the industry players, as well as interoperability between different types of devices for different types of markets. OIC is a consortium to join to define that.
And it's open.
It is open.
And it's open
IPR.
source?
It's open source and actually has well-defined IPR policies, which it isn't available in the market by other consortiums today.
All right. So what do you think about IDTechEx?
I think it's been a great show. It's one of the pioneers of wireless sensing networks. It has the right mix of type of mix of technologies that are now becoming relevant. They've been added for wireless sensing networks, for energy harvesting, for energy storage, for printed electronics for years. And now all of those technologies are becoming relevant for Internet of Things. And so they're riding away. IDTechEx is a great place for companies to come to gather information, to network, as well as to learn on what's happening in the industry.